Hello, my name is and this is Morn.
ของเนี่ย
so,
ไม่ใช่เหล่านั้น
Okay, good evening, teacher Geng. Today we're going to be recording our celestial sphere,
delicious
Celestial sphere, So first,
no.
this one.
Side,
This
okay.
one.
So let's get started with celestial sphere. So, okay. So this is our celestial equator,
ไม่
as you
ต
can
อนนี้สัตว์
as you can see from the screen line. So the celestial equator is the projection of Earth's equator onto the celestial sphere, which is the lid, and it will form a great circle that divide the sphere into northern and southern hemisphere. So the significance of the celestial equator is the reference line for the equatorial coordinate system, and also helps in understanding of the stars' positions on the celestial sphere. So for the key features of the celestial equator is it will always perpendicular to the celestial poles, because the celestial pole gonna be like go through this, and the celestial equator will be the plane that perpendicular to them. And also the celestial equator will divide the sky into equal halves for the observers on Earth. So next one is the ecliptic. So for our model is the purple strips that will make the 23.5 degree to the equator. So it's the apparent path of the sun that traces across the celestial sphere over a cross of a year. So it will be the results of the Earth's orbit around the sun. So the significance of the ecliptic is that it will represent the plane of the Earth's orbit. And it's also crucial for understanding the seasons changes and also zodiac signs. And for the key features, as I've mentioned, it will tilt it at 23.5 degree relative to the celestial equator, as the axial of the Earth will tilt it also, and also it will crosses the celestial equator at the vernal and autumnal equinoxes. So for the next one, the relationship between celestial equator and ecliptic. So it will have the inclination and the intersection. As I've already mentioned, also the inclination is at the 23.5 degree tilt between the celestial equator and also the ecliptic. And this will explain the changing of the seasons, and also it will vary the day lengths also. And for the intersection, it will intersect at the vernal equinox and also the autumnal equinox, which is only 2 points. And for the impact of observations, the ecliptic will marks as the sun path, which is right here. And the celestial equator will help tracking the stars and the planets relative to the Earth's axis. And also the angular distance between these two will determine the sun's position in the sky. And the next one is solstices and equinox. So for the solstice is when the sun's reach is highest and the lowest point related to the celestial equator, marking the longest or the shortest day of the year. And for the equinox is a day that the sun crosses the celestial equator, which will result in the nearly equal day and night lengths, as you can see from these diagrams. And for the key dates of the equinox and the solstice is 21st March for the vernal equinox, the 23rd September for the autumnal equinox, the 21st June for the summer solstice, and the 22nd December for the winter solstice. And for the day length variation, as you can see from this slide, I think we don't need to mention that. And for the reasons of the solstice and the equinox they happen because the Earth's axis tilted for the degree at 23.5 degree, and which vary the angle of the sunlight throughout the year. And at solstices, only one hemisphere is tilted towards or away from the sun, which gonna maximize or minimize the daylight, which results in the longest or shortest daytime. And for the sun path, so sun's path of each equinox and solstice. For the vernal and autumnal equinox, sun will rise exactly in the east and also sets exactly in the west. And for the sun crosses the celestial equator, it will result in the equal day and night time. And for the summer solstice, the sun will rise in the northeast and sets northwest. And follows the high arcs in the sky. It will provide the longest daylight hours, while winter solstice will rise. The sun will rise throughout the southeast and set to the southwest. And also vice versa for the summer solstice. It will result in the shortest daylight hours. And for the next one is the reference points of the equatorial coordinate system, which Born gonna explain it. Hello, teacher King.
Hello, teacher King. So next I'm going to explain the reference point and frame on the equilateral coordination system. The reference point is just to referencing so you can know better where the celestial body is. So we have the celestial plane, which is the uh, celestial equator, which is a projection of Earth equator, and also the reference point, which is the vernal equinox, is where the celestial equator intersect with the ecliptic. So next, I'll talk about the declination and right ascension. Declination first is to measure the angular distance of object north or south to the celestial equator, as you can see here. We do have some measure tape here. So this one can use to measure the declination, and also is analogous to the latitude of Earth. The range is 90 degree or to negative 90 degree. It used to determine the how far the celestial object from to the celestial equator, and also help observer estimate how high the object will rise in the sky. The next one is the right ascension. The right ascension is the measurement of the angular distance of the object eastward from the vernal equinox, and it's also analogous to longitude of Earth. So we measure it in hour, minutes, and seconds, where 24 hours equal to the full 360 rotation of the celestial sphere. And this used to indicate the time which the celestial object will be highest in the sky, and also used to track the star position and plane observation. So we will answer the first question is how to identify declination from the observer in the horizontal coordination system. So we can find declination. We use the object altitude in the culmination, which is the highest point which the object is, and also the observer latitude. So the formula is the declination equal to the altitude plus the observer's latitude negative nine, then decreased by 90. We have some example here. So for if the observer at the 20-degree north and star culmination at the altitude of 70-degree, the declination will be 3. Next, we're gonna use the declination to identify the circumpolar square. Sorry, circumpolar stars. So the circumpolar star is the star that visible all night sky. They appear to circle around celestial pole due to Earth rotation. So the significance of circumpolar star is used to provide a constant reference for navigation and timekeeping. And the key to identify is the observer latitude. Well, So if the declination of star is more than 90 divided by absolute of observer latitude, the star will be a circumpolar star. First example, if the observer at the 45-degree latitude, star declination more than 45 are circumpolar. If it's observer at 60-degree latitude, the star declination more than 30-degree are circumpolar.
Wow.
Thank you very much
Thank you.
to the
And,
listening our
and that's
scope
all.
presentation. Thank you.
That's all for our presentation for the celestial sphere. Thank you. Please keep up the good grade, teacher. Bye bye.